to continue on our exploration with exponents, and we're going to look at some different rules in this video that didn't really fit in the first video that we did. So we're going to learn how 0 is used as an exponent. It is very different from multiplying by 0. We're going to look at negative numbers as exponents. We're going to look at the quotient rule for exponents, and then combinations and practice applying more than one rule. So the rule for 0 as an exponent is counterintuitive. It's not something that we logically come to. If I raise something to the 0 power, the answer is 1. It could be anything to the 0 power. I could raise pi to the 0 power and it would be 1. So when I'm working with that, if I have 6 to the 0 times 6 squared, let's think about that logically with our rules. In the past, we learned if we multiply two like bases, we add the exponents. So 0 plus 2 is 2. So using this rule isn't really handy in this case because I already know to do 0 plus 2. But there are other times where I will have a variable raised to a 0 power, and I need to know that basically gets rid of the variable. So if I have a to the 0 power, I have the variable a, but when I raise that variable to the 0 power, it's no longer a variable. It just becomes the number 1. So everything in this slide to the 0 power is going to be 1. But in C, the negative is out front versus in B, it's inside the parentheses. When the negative is out front, it remains in the front. And then in part D, I can't combine 13 and 2. Those aren't like bases, but 13 to the 0 is 1, 2 to the 0 is 1, and I get a final answer of 2. So this rule is not difficult, but it's something you have to remember because a lot of students want to say 0. They want to put 7 to the 0 power is 0, and that's logical using what we know about 0. But we have to keep in mind the rules for exponents follow different properties. Negative numbers, exponents, also have a weird situation. They cause anything to flip. It doesn't change the sign, it just causes it to flip. So look at 3 to the negative 2. I flipped that. 3 is 3 over 1, which would flip to 1 over 3. When the flip happens, you get rid of the negative exponent. Your final answer cannot have a negative exponent in it. That is not fully simplified. So be on the lookout as you're working problems. The final solution that you enter has to have a positive exponent. So 4 is really 4 over 1. So to get rid of that exponent, I'm going to flip that into 1 over 4 squared. B, I have 1 over 4 to the negative 3. The negative exponent is going to flip it. And you could write that as 4 over 1. That's fine. 4 cubed in our calculator is 64. 3 over 5 to the negative 2. To get rid of the negative, I'm going to flip it. Then I'm going to apply my exponent rules, and I'm going to distribute that 2 to the 5 as well as the 3 to get 25 over 9. In part D, I'm taking this a step further. I have 2 over 1 and 5 over 1. I need to flip them to get rid of the negative exponent. But 2 to the 1 is just 2, 5 to the 1 is just 5. If you are not a fraction person, you can go to the Web 2.0 calculator and type in 1 divided by 2. The division symbol is on the screen, or you could use the symbol by the question mark, plus 1 over 5. And that would give you 7/10. In E, I have m to the negative 3. It's m over 1. So when I flip it, I get 1 over m. And remember, the exponent follows you with the flip. It just becomes positive. Here is a formula slide. I strongly encourage you to copy this down and keep it in front of you as you work through the exponent problems. Because again, this is not like our usual arithmetic with numbers. These are new rules that we're applying to exponents. if I want to change from a negative to a positive exponent. In the first one, I have two negative exponents to deal with. You can still flip it. So because the 3 is in the bottom to the negative exponent, it comes to the top and is positive. 5 to the negative 2 flips the position and goes down to the bottom, but becomes positive. Then I can use my calculator to simplify it. In B, H and M need to flip places to become positive. But K is not a negative exponent, and it can stay exactly where it is. In part C, I would flip the inside first. That's not the only way to get here, but I would flip the inside to get rid of the negative. Then I would distribute the 3 to everyone. So the 3 is going to go to the 2 and to the y, and then here it's going to go to the x. When I have an exponent raised to an exponent, I multiply. So 2 to the third is 8. 3 times 3 is 9. X to the 2 to the third, 2 times 3 is 6. What is the quotient rule? Well, we learned when we multiply two like bases that we add the exponents in the expression. When we divide, we do the opposite operation and we subtract. Now notice it's the exponent in the top minus the exponent in the bottom. That's really important. Notice there are no negatives here. You need to clear out your negatives before you start applying this process for most people. You don't have to. There are many ways to get to an answer, but I recommend it. So I have like bases being divided. 7 minus 5 is 2. Using my calculator, that is 16. In part B, I have like values being divided. I'm going to subtract, and I get 4 to the negative 2. We are not allowed to have negatives in our final answer, so I need to flip it. And I get 1 over 4 squared, which is the same as 1 over 16. In part C, there are multiple ways to get here. You could flip this as x to the 12th over x to the 6th. That could be your first step. I did negative 6 minus negative 12 just because I wanted to show something different. Because minus a negative becomes plus a positive. So this becomes negative 6 plus 12, which would be positive 6. But you could definitely flip it and then subtract. 4y to the negative 6 has a negative exponent. I need to do 1 over y to the 6th, and then I'm going to leave the 4 in the top. Here I have a series of numbers. I need to bring the n to the negative 3 to the bottom so I can get rid of that negative exponent. And then I'm going to use my calculator to do 8 to the 4th and 8 to the 5th. Which gives me 8 to the negative 1. 9 minus 10 is negative 1. Negative 3 minus 2 would be negative 5. I'm going to have to move all of that to the bottom. You could have started by bringing the n down here and then doing the 3 plus 2. That would still get you to the same place. Doesn't matter what road you take as long as you wind up at the same place. Here is a slide that has every formula in its comprehensiveness of what you need for exponents. You can definitely pause this and copy it down, or you can use the slide from the previous lessons. Here we're going to do some practice with combinations of the rules. So if I have 3 to the 4th power squared divided by 3 to the 3rd, the first thing I would do is distribute the 2 and do 4 times 2, which is 8. Now I have like bases and a quotient, so I can subtract using my rule of arithmetic. 8 minus 3 is going to be 5. Using my calculator, 3 to the 5th power is 243. In the bottom, I'm going to take that, and I don't have an exponent in the first set of parentheses, so it's going to be 4x squared. But my second set of parentheses does have an exponent I need to distribute. Now that it's been distributed, I have 4 to the 1 times 4 to the 2. 1 plus 2 is 3. X squared times x squared is my product rule, so I'm going to add my exponents. And I'm going to do 2 plus 2, which is going to be 4. In part C, I have a negative exponent. So the easiest way to tackle this problem would be to use the flip to get rid of the negative. But this example isn't using that. But I could flip this to 6 divided by 5y squared, and that entire thing would be raised to the second power. What this did was it distributed the negative 2 first. So everyone got a negative 2. Negative 2 times 2 is negative 4. Negative 2 given to my denominator is 6 to the negative 2. Now, everyone with the negative exponent flips position. So the 6 comes to the top, the 5 and the y go to the bottom. Then I use my calculator to simplify 6 squared and 5 squared. And the next one, there are multiple ways to get to the answer. I would distribute the negative 2 first. So I would do negative 2 times 2, which is negative 4, negative 2 times y, which is negative y. I have 3 to the 9th power divided by 3 to the 3rd power. I could combine that into one step, or I could create a new step. Notice I have two quotient rules happening here. 3 to the 9 minus 3 would be 6. Negative 4 minus negative 4 is 0. Anything to the 0 power is 1. That is why there is no x in this problem, is because it becomes x to the 0. Negative 2 minus 1 is negative 3. Because it is negative, it's going to go and flip to the bottom. I'm going to use my calculator to figure out what 3 to the 6th power is. Try this one on your own by pausing the video. The key here is to distribute the 4 to the parentheses, the negative 3 to the parentheses, the negative 8, and the 10, which is what I did. Now that everyone's distributed, I'm going to apply the quotient rule. I have 4, and I have negative 3. So I can add 4 and negative 3. That's where this comes from. I have r to the 4th, r to the negative 3. So adding 4 plus negative 3 is the same as 4 minus 3. Same thing at the bottom. Once I get all of that simplified, now I can deal with the fact that I have a quotient rule. I have 8 to the 1 divided by 8 to the 2. 1 minus 2 is going to be negative 1. So it actually is up here when it's 8 to the negative 1. The negative flips it down. R to the 1 minus 2. The same thing happens. When I do that quotient rule, it's coming up to the top. So r to the negative 1. I need to flip it down to the bottom to get the answer. So the key is to take these step by step and to never have a negative exponent as a final answer. Then be sure you have your formula sheet handy so you can practice with the formulas in front of you, and eventually you'll find you don't need that sheet anymore.